All right, welcome everyone. Today we're going to finally start diving into chatbots. Now, before we start diving into our lecture today, I do want to do a quick breakdown here. So far, what we've learned when we started off our AI learning process, we started by saying, hey, well, AI already exists, but I want to make sure that I know how to utilize it. So we learned how to utilize AI through the means of prompt engineering and or receiving code review, but not answers, right? And we dove into the concept of deep learning. That concept was covered yesterday, and we see that we have our AI machine learning. There's the deep learning portion, which is essentially generating a model with a tensor neural network that can learn to make accurate predictions. And we learned how to build this yesterday within our multi-classification network here, where we were actually able to feed 13 features straight into our neural network, get a possibility. We were able to work with data. We talked about how to standardize that data and scalarize it, or excuse me, and scale that data. We then broke it up into training and testing batches. And we worked through our neural network by doing the forward and backward pass. Forward pass by actually feeding it and making a prediction, and the backward pass through back propagation with our optimizer of atom and our criterion of cross entropy loss to be able to fix our weights and biases and actually allow our model to learn. And by the end of yesterday, I believe our model was around 87% accurate. We also mentioned a couple of optimization portions where we were able to add something called dropout layers and even ReLU functions to ensure that our model is even more accurate and can learn quicker. All right. We also talked about the importance of data altogether, how we have to prep our data in order for a model to learn properly. Well, that was diving into the left hemisphere of AI, right? Something that pretty much the starting point where AI started, which is just machine learning or deep learning, recognizing patterns, making accurate predictions. Well, today we're going to start diving into something called NLP, which stands for Natural Language Processing Bots. All right. And we're going to start talking about the history of where that came from, what actually falls inside of it, and just note that nowadays we are interacting with natural language processing bots pretty much on a daily basis, right? Every single time I start typing out something inside of, let's just say, the extensions that can generate code, they see me start typing out a function definition, or maybe I have some sort of comment body and I start typing out a function definition, such as GitHub Copilot. Well, GitHub Copilot sees what I'm already creating, and from maybe a couple of lines of comments or a couple of lines of code, it's able to say, oh, this is what you want to build. Here's what the rest of it's going to look like. And we're going to talk about this process of how something like GitHub Copilot works, something like ChatGPT works in order to be able to make accurate decisions and actually provide an answer. All right, let's go ahead and dive straight into today's lecture. We're going to get a quick introduction into what natural language processing means during the first portion of our lecture. We'll talk about a couple of different examples of natural language processing AI bots that already exist. We'll talk about the different types of AI bots that we can work with. We'll then break up, do a little bit of research that should take maybe about 30 minutes, and then we'll come back and start talking about a very important tool that we'll be utilizing the rest of the time that we are here in class, not only during this process, but probably for the rest of the cohort, which is going to be Regex. We're going to break down regex in Python, and we'll talk about why we're even learning regex in the process of the NLP spectrum. All right, at this point, does anyone have any questions over what we'll be covering today? And Gary, yes, that is correct. That's the sound that he is making. Saw that in the chat. All right. If there aren't any questions, then let's go ahead and dive into our curriculum portion first. I'll go ahead and open this up a little bit so that we can see it. Can I get somebody to read this first paragraph, please?
What are AI chatbots? AI chatbots are computer programs designed to simulate human conversation using artificial intelligence, natural language processing, aka NLP, and often machine learning. They began as rule-based systems in the 1960s with early examples like ELIZA, 1966, which mimicked a psychotherapist using simple pattern matching and scripted responses. In the 1990s, bots like Alice advanced the concept with more sophisticated scripting but still lacked understanding of context. With the rise of machine learning and big data in the 2010s, chatbots evolved dramatically. Siri, Alexa, and Google Assistant introduced voice-enabled interfaces with NLP capabilities. The real leap came with deep learning and transformer-based models like OpenAI's ChatGPT series and Google's BERT, which has enabled generative AI chatbots to understand context, nuance, and user intent. Today's AI chatbots, such as ChatGPT, can hold dynamic, human-like conversations, assist with customer support, education, and personal productivity, and are integrated into platforms from websites to mobile apps, representing a significant evolution from scripted responders to intelligent conversation agents.
All right, awesome. So just a little bit of a quick introduction here, just to take it a step further. It's giving us a history of how AI started. Now, this ELIZA here, which was created in 1966, something that I want everybody to make sure they annotate is that it's a simple pattern matching and scripted responses. What does that mean? Anybody take a guess as to what that could possibly mean?
It looks for the amount of times a specific word pops up, and then we'll have a calculated response based on that.
All right, awesome. So what you're saying is it receives something like, hey, what day is it today? And it may be able to recognize keywords such as what. Oh, probably want to do that in yellow here, such as what, day, and today, right? And then from there, it may have something called a decision tree, where it starts looking through all of its different options, right? Because in this case, remember, these are scripted solutions. It already has some sort of database stack. And inside of this database stack, it might have something that already says this is answer one, and answer one may be returned if keywords one or two are met. It may have something like answer two. That might be if keywords 13 and 15 are met, and so on, right? And it may fall down to a huge pattern there where it's able to identify a series of keywords and return the appropriate response to match those keyword prompts. Well, that doesn't seem like something that we're used to seeing, right? Because nowadays, when I talk to AI, if I go over to ChatGPT and I ask it, hey, what day is it today? If the program here, like Eliza, wasn't programmed to be able to answer questions like what day it is, it would simply not be able to understand my question. And it may return something like, I don't know, what day do you think it is? Right? It might be like its default statement to return something that asks me a question. But ChatGPT doesn't do that. ChatGPT is actually able to understand each one of these words, give them a specific value, break it down, look through its already designated database, say, hey, I don't have the right answer, and then generate intelligently through deep learning and come up with a new answer that it can deliver to each specific user, right? So Eliza already has a preset response. There you go. All right, Carlos, I saw your hand go up.
Yeah, so is that basically kind of the same logic that like the whenever you call customer service and you get like a bot, is that kind of the same? Like, are they just kind of looking like for keywords? Is that, or are they kind of using something else?
That's a great question. Yeah, so let's say I call a bot. Let's say I'm calling an insurance bot, right? And then that insurance bot is saying, "Hey, what is it that you would like to accomplish today?" And then it says, "If you, um, it tells me you could say something like paying your bill, right?" And then you say, "Hey, I want to speak to a representative," but that's not one of its default answers. It just goes, "I'm sorry, I couldn't understand you. Can you please try again?" And then you're saying a different set of keywords to this AI bot, right? It's receiving the input and it's looking through all of its already preset scripts. But because it doesn't have something that meets the keywords that you are trying to bring up, it just keeps telling you, "I'm sorry, I couldn't understand you." And then you're just continuously trying to figure out a way to tell this machine how to connect you to the right person, right? So that's a really good example there. All right, awesome. Now, how do they work? Can I get someone else to read this?
How do they work? From a technical standpoint, chatbots function by processing user input, typically text or voice, through through several layers, beginning with natural language understanding (NLU) to interpret the user's intent and extract relevant information. This is followed by a dialogue management system that determines how the bot should respond, using either predefined rules or machine learning models trained on large data sets. The response is then generated using a natural language generation (NLG) and sent back to the user in human readable form. More advanced AI chatbots, like those built on transformer models, GPT, use deep learning to predict and generate coherent, context aware responses across a conversation. From the user's perspective, this process is seamless. They input a question or a command and receive an intelligent, often conversational response almost instantly. The chatbot appears to understand and respond naturally, creating an interactive experience that feels human-like, even though it's powered by complex data pipelines, algorithms, and model interface under the hood, or inference under the hood.
All right, awesome. Now let's go ahead and take a deeper look or just a couple of highlights there. So NLU, keyword is there. Natural language understanding. So intent detection is the user asking a question or giving a command. And then entity recognition, extracting items like data, names, or product IDs. Now, natural language generation takes internal data or logic results and produces a human-like response. Example, converting item, converting item is out of stock into sorry, we're currently out of item. All right. Another thing that I would like to highlight there is that NLU is on the way in to the model. So I'm just going to go ahead and take this AI chatbot here and take it out of our spectrum. Let me move some images around here. All right, so NLU is happening as it's being fed into the chatbot, and it's happening because my machine is trying or attempting to understand my command or question in order to best provide an answer. And so NLU is from as it's receiving information, right? It's still happening within the bot itself, but it's before data is even being processed or before it starts even generating an answer. There's a process where it's trying to understand more of a context to be able to give me some sort of human interaction there. And then on the way out, well, that's our NLG. Oh, there you are. All right, which is our natural language generation. So NLG, I understand, or let's say the bot understands my intent and it does, I'm going to say it does what it can because it won't always be able to achieve this to be able to provide a response. All right. Now let's talk about the different types of chatbots. All right, and we're going to break these chatbots down in a way that we're going to talk about their ability to generate a response and in their ability to be able to hold a conversation. Now, let me give a quick look at this chart before we even start looking into these different types of bots, so that we can kind of get a general idea as to what I mean. All right. So when we're talking about these bots here, maybe a little higher. There you go. All right, when we're talking about these bots, we're going to be referencing to them again in their base of being able to hold a conversation and also in their base to be able to hold a generation. There's three types of chatbots. There's rule-based chatbots, which we already talked about. They know an exact number of output that they can actually give you. There's retrieval-based chatbots where machine learning is actually involved. So they checked, hey, do I have a direct answer depending on what is it this person gave me? If I do not, then I will generate an answer for this person so that they can actually have some information. And then there's generative chatbots, where one, it checks, can I actually give this person an answer from what I already have inside of my database? I cannot. Well, I'm going to generate one. Not only am I going to generate a general one, I'm going to generate something that's specific. I'm going to conduct some research and make sure that I'm giving proper answers. And then in their ability to hold conversations, you can see their difference there. So response generation, it's simple dialogue tree, meaning that once I actually receive some input in a rule-based chatbot, it just looks at keywords and tries to find which one of its already recorded answers can be given. There's machine learning, where I'm feeding it a data set of this is a series of queries. This is a series of possible answers that can match those queries, kind of like we did yesterday with our multi-class classification model, where we give it a series of features and we were able to receive a series of outputs. Right? So both of those are still within the retrieval-based chatbots are still within the deep learning spectrum. The simple dialogue tree is more of a else if statement, saying if these keywords are in here, then return this. Else, if these keywords are in here, return this. But notice that neither rule-based chatbots nor retrieval chatbots are able to have an open-based conversation. So for example, I can start asking them questions regarding things that they weren't designed to be able to answer. Whereas generative chatbots, they don't work in that way. Generative chatbots are able to look for information and generate information. Yes, they have already been trained to a specific extent. That's just for performance to make sure that they can actually have some, I would call it a basis to be able to generate answers. But they go above and beyond in the fact that if it doesn't have those answers already pre-programmed or it doesn't have a way to find those answers within its learning model, it will generate those answers. That's why it's a generative chatbot. And that's also why it can hold an actual open conversation. I can talk to it in many different ways, in many different tones, and carry out an actual conversation with this bot and almost in a human-like fashion. So much so that I think it's starting to become a phenomenon. I can't remember what the name is called, but I just saw it last night where people are starting to talk with AI so much that they're like developing form of emotional attachment to AI. So just for everybody out there that's developing, please don't become too reliant on the AI machines. All right. Now that we broke that down a little bit, let's actually start talking about the types of chatbots and take a look at some text, giving us a couple of examples of how these chatbots work. So first, let's break down rule-based chatbots. Can I get somebody to read that, please?
Rule-based chatbots. What is a rule-based chatbot? A rule-based chatbot appears on a set of predefined rules and patterns, often using decision trees or keyword matching to guide the flow of conversation. These bots do not understand context or intent beyond their hard-coded logic and are typically designed for specific tasks like answering FAQs or guiding users through menus.
All right, awesome. So they have a specific purpose. They are more of an else if statement. When I hear a decision tree, that's the first thing I think about. I think of just conditional statements, or maybe even conditional statements that are nested within other conditional statements, right? And then something kind of like a literal tree. Oh, hello. That's not what I meant to do. Something kind of like a literal tree that looks as such, right? Where we have a node, and then that node is attached to two nodes. Then we have a different decision to make there, and a different decision to make there. Right. So that's something that I think about when I think about a decision, or that's the visual that I see when I think about a decision tree. All right. Now, response generation within this rule-based chatbot. Rule-based chatbots generate responses by matching the user's input into a fixed set of rules or triggers. For example, if a user types in, "What are your hours?" the bot searches for keywords like hours and replies with a preset message. There is no learning adaptability. Every valid input must have a predefined rule to match. All right, so we get that tree there. We say, "Hey, what are your hours?" That comes in through. It gets fed through the AI model. It identifies, hey, we have something like hours that's being represented here. Cool. So we give it into our node. We say, hey, is there a keyword that was identified? So can we even go into this keyword? Yes, we can. Is it hours or is it staff? And then we say, oh, what we're looking for is actually hours. All right. Now, is it asking for uh, what are your hours? Or is it asking for a when concept, right? And if we're looking for a what concept, well, then it returns this node that has a preset message inside of it saying our current hours of operation are from 7 to 5. All right. And just like that, it gets fed down the decision tree and a already pre-programmed response is being returned. There's no learning process. There's no generation of new answers happening here. It's just simply coming down a decision tree, matching the best decision that it can, and returning that response. Might not be what the user is even looking for, but that's the best response that can match their prompt. All right. Now in the conversation domain. So rule-based chatbots are closed domain systems. They can only handle questions and interactions within the specific scope they were designed for. If a user deviates from the expected inputs, the chatbot often fails or gives an irrelevant response. All right. Any questions regarding rule-based chatbots? Awesome. Let's start talking about retrieval-based chatbots. Can I get somebody to read that, please?
What is a retrieval-based chatbot? Retrieval-based chatbots select the most appropriate response from a pool of predefined responses using machine learning and natural language processing. These bots rely on similarity measures and intent recognition to find the best match to a user's input. Response generation. Retrieval-based chatbots use models to interpret user intent and then retrieve the best matching response from a database or response bank. They do not generate original responses. Instead, they choose from the existing ones, ensuring that answers are relevant and controlled. Conversation domain. These chatbots are usually semi-closed domain, but can scale to larger applications with a wide set of intents. While they are more flexible than rule-based bots, they still struggle with true open domain conversations because their responses are limited to what is pre-written.
All right. Awesome. So let's break that down. This is our rule-based chatbot, right? Where we have our what-if statements. Well, a retrieval-based chatbot is more like our weights and biases, though, or excuse me, more like our deep learning model that we worked in yesterday. The main difference is that yesterday, when we were working within this image, what we were doing is we were feeding features where each one of those features had a specific decimal point, something like 5.03, et cetera, et cetera. Well, now what we're feeding into this chatbot will be a series of keywords. So let's take that same prompt where we're saying, hey, what time is it? Or what are your hours of operation? Well, it'll go through the process of recognizing keywords such as what, hours, and operation. Maybe you'll group things like are yours, and I guess I can't spell. Maybe I'll group some things like are yours and operation. And just like that, it'll create 1, 2, 3, and 4 features that it can feed our model. So say what are your hours operation? And they'll give them a tokenized value. So let's say this is 5.0 or 5.5. This may be something like 3.2. This may be something like 12.134. And this one might just be something like 1. From there, it'll get fed into our AI model. And when it comes out with an output, instead of having an activation function that runs like this, to be able to percentage-wise, it's going to look pretty much exactly the same. Yesterday, what we had was a simple grade key of answers between 1 through 5, right? And from there, we were matching those to the index, or excuse me, 0 through 4. And we're matching those to the index of A, B, C, D, and I believe F was also one of them. So that was our example yesterday. Well, in this case, what we'll have is we will have a massive text file where in this text file, We'll have a series of texts of different options that are going to be permitted to us. And it's going to continue down. Again, it's not generating a brand new answer. It's just utilizing machine learning to, instead of saying if else statements, their deep learning model itself is going to decide which one of these options would be the best answer for the prompt that I gave it. So let's say in 13, we have hours of operation are between 7 to 5 p.m. Well, what our model may output at the end of this would be something like, hey, at index 12, we have a match of maybe something like 45%. And they'll select that text saying hours of operation are between 7 to 5. Remember, this is index 12. That's where we're getting the item 13. We start counting from 0. And then that would be what gets returned to the user. All right. Does anyone have any questions over retrieval-based chatbots? Let's hear it, Alex.
So with what we've seen, it's like an 80 to 90 something% chance of getting the correct one if it's trained the way that we've seen so far, at least. With this model, wouldn't it give incorrect responses a decent amount of the time?
Depends what you mean by a decent amount of time. If we're saying that our model is accurate 87% of the time, I would say that it would only give incorrect responses rarely, right? Maybe 1 out of 10 people would receive an incorrect response. Um, and with that said, more than likely what's going to happen to the user after that is they're going to get frustrated and they'll just prompt the model again, and then the model may come up with a different answer. But yes, the opportunity of a model giving an improper response is definitely there. All right. Any other questions? Let's hear it, Andy.
So in this case, where is the delineation between the NGU and NGL? Are we the where your pointer is right now, is that the start of the NGL now?
Yeah, so this would be the start of the generation, right, for the response. So now that it knows the proper response, then it would do the NGL process,
Okay.
all right, which is the generating a response. And this might be something like, depending on context, respond with a set of pre-designed, we'll call them attitudes for now. All right. For example, oh man, when was it? It wasn't that long ago where Twitter developed an AI. I think it was named Tay, Tay, and I'm not sure if everybody heard about it, but
Microsoft, I think.
oh, it's Microsoft. Awesome. Yeah, and you were able to like make specific prompts with a context. Like if you were rude to the AI model, it was rude right back. So like people started just using it to kind of make fun jokes with that. And then so if that's the process for the generation, the understanding would happen before we meet our AI model. So this is the understanding of the prompt. All right, go ahead, Andy.
So it's not necessarily generating response, right? It's just putting things together that would match the response to the input. The
Right.
generation would be like where nothing is pre-constructed, um, and it just makes something up.
I see where the confusion may be coming from. Yeah, so this is not a generative model. This is a retrieval-based model, right? Where we receive a prompt, we feed it, and matches it to the best of its ability. The only thing that it's generating, it's the user readable response, right?
Oh, okay.
It's not generating the actual answer, just the user readable format. Whereas our rule-based one wasn't doing any of that at all. All right. All right, now let's go ahead and move into our final type of bot, which is our generative chatbots. Can I get someone else to read this portion here?
What is a generative chatbot? Generative chatbots are deep learning models, especially transformer architectures like GPT, to generate responses word by word. They don't rely on pre-written answers, but instead form new responses based on training data and contextual understanding. Do you want me to continue?
No, I'll go ahead and take it from here. Thank you. All right, so response generation. These chatbots are using neural networks trained on a massive data set to predict the next word in a sequence, allowing them to craft entirely new responses on the fly. This allows them to handle novel queries, express creativity, and adapt to various conversation tones and topics. Conversation domains, generative chatbots are capable of open domain conversations, and they can discuss virtually any topic, shift context dynamically, and provide nuanced, detailed responses, though they may occasionally generate inaccurate or unexpected answers. This is called hallucinating. All right. Now, what does that mean? Here we saw our bot, or rule-based bot, which was, or excuse me, our retrieval-based bot, which was trained on a set of answers. Well, a generative bot is not trained in a set of answers. A generative AI bot is actually trained on an entire vocabulary. We're able to give it an entire context book, such as I think a good example that I saw, a guy made a natural language processing chatbot that was trained on data from the Three Musketeers. Right, it was given the series of books of the Three Musketeers as his vocabulary. It broke it down for each one of its actual words, and then it was able to learn how and when to formulate sentences in the same format that was used in the Three Musketeers. So when you were talking to the chatbot, it was answering to you as if it was a character within the Three Musketeers book, which is really, I think that's really cool. I'm also kind of just a weird nerd about this stuff, so yeah, that was a pretty funny experience to be able to see somebody to do that portion there. I'm not gonna try to draw that out because I feel like if I try to draw it out without learning the more complex stuff before we get there, I'm just gonna end up confusing everyone. So I'm just gonna leave that drawing for later, and then we'll draw it out and break down generative chatbots in detail later on. Does anyone have any questions about generative chatbots? All right, perfect. Well, then that takes us back to our image that we saw earlier. I'm sure everybody can see the familiarity there now. And let's take a look at a couple of examples there. So we have use cases for each chatbot. A use case, which is a FAQ bot. It is a rule-based bot. Predictable questions and answers. Oh man, I can't remember. I think the last time I saw a rule-based spot was probably when I was trying to book a flight through some website, and they had something in the bottom where it was like some bot that populated, and it was like, "Hello, my name is so and so. I'm here to help if you have any questions." And at the time, I didn't understand that that was just an AI bot that I was talking to. And I remember formulating questions saying like, "Who do I need to talk to?" And then the little bot being like, "I'm sorry, I don't understand you. Is there anything else I can help you with?" And I was just losing my mind. So now that I know a little bit more about what chatbots actually are, I understand why that little chatbot was consistently telling me that it had no idea what I was trying to ask it. E-commerce product assistant. So that's a retrieval based, requires context and is aware accurate responses. All right, we have a personal assistant. That's a generative chatbot. Mental health companion, definitely a generative chatbot. And we're going to talk about mental health here shortly. And then we have the IVR phone menu. That's a role-based chatbot, right? If I'm sure we've seen it a chatbot before it populates saying, "Hey, in case you don't know how to move through this, please let me know." For example, I think Microsoft Word used to have that clip. I think its name was Clippy, I'm pretty sure, that you could click on and it would tell you like, hey, what do you need to know? And you could ask it like, how do I format this text to look in a specific way? And then Clippy would walk you through the process of like, well, first you need to click on this button and walk through this. That's a rule-based chatbot, right? It was telling me, depending on what it is that I requested, a specific set of steps to be able to accomplish my task. All right. So here we go into a summary, types of chatbot summary. Rule-based, retrieval-based, and generative chatbots differ fundamentally in how they produce responses at a range of conversations they can support. Rule-based chatbots follow strict if-then logic and can only handle predefined interactions, making them ideal for narrow, predictable tasks. Retrieval-based bots improve flexibility by using intent detection and selecting responses from a curated set, providing more dynamic conversations while maintaining control. Generative bots, powered by advanced AI models, are the most sophisticated, able to understand and generate context-aware natural language across broad topics. However, this power comes with the trade-off of needing more data, compute, and careful monitoring for accuracy and safety. All right, now let's talk about the ethical concerns regarding chatbots. Can I get someone who hasn't read a paragraph yet to read this portion?
As chatbox technology advances, developers must navigate several ethical concerns to ensure responsible and transparent use. A key issue is user transparency, especially regarding how chatbots collect, store, and use personal data. Users should always be informed if their conversations are recorded or used for training purposes. Another concern involves chatbot personas, such as the infamous case of Microsoft's Tay, which quickly adopted offensive language after being exposed to toxic inputs on social media. This highlights the risk of the unmoderated learning and the importance of setting clear behavioral boundaries. Additionally, chatbots can employ manipulative communication techniques such as mimicking human empathy or persuasion, which may mislead users or exploit trust, particularly in customer service or mental health contexts. Developers must be cautious to design chatbots that are not only effective, but also ethical, transparent, and aligned with user safety and societal values.
All right, awesome. Thank you so much. All right, when it comes to ethical concerns, I think this is definitely going to be something that evolves moving forward. There's no actual legal field within technology yet that has rules saying, hey, you can or you cannot do this. There is legal rules as far as how user data is managed, but that's at a way higher level than the developer level. So we don't necessarily need to worry too much about that unless you're generating your own chatbot and you're deploying your own application. General rule of thumb, be as transparent as possible. If you have a chatbot interacted inside of your machine, inside of your front end, make sure that its very first statement is say, "Hey, I am an AI chatbot. My name is so and so, and you can talk to me about this specific topic." Right? And then somewhere along in your site, make sure that you have something at the bottom saying user data is not being exploited, nor is it being captured. As we all know, I mean, what was it, like 5 years ago, where there was the whole fiasco regarding user data? Was it even 5 years ago? I think it was around 5 years ago. I specifically remember like TikTok getting all kinds of weird questions in front of Congress about like its ability to connect to Wi-Fi and all this other stuff. Just make sure you have a clear, transparent way to tell the user this is not a person, this is a chatbot, so that they understand they're talking to an actual robot and not a person. And make sure that you're not storing their information, right? As prompts are being received, do not put those prompts inside of your training data sets. do not put those prompts inside of any sort of database. Those prompts should simply be processed through the model to generate an answer and then returned, right? Make sure you turn off the model's ability to be in training mode and that the model is only analyzing that data one time to be able to generate a response. And after that, that query should just disappear. It could still be showing up in their front end, but it should not be captured in any sort of way. If you need additional data to train your bots, it's perfect thing to utilize generative AI for. All right, go to generative AI, say, hey, I have a model that does X, Y, and Z. This is an example of a couple of data sets that I already have pre-programmed for it to answer. Please give me a CSV file with 3,000 different prompts and 3,000 different targets that I can actually feed into my model. And generative AI will actually give you a CSV file with a bunch of fake data that you can train your models with. Do not utilize user data to train your models. All right, Michael.
How can you be sure of generative AI providing like correct training data?
Yeah, that's a great question. Um, I think you would have to make sure that you have a specific program to validate your training data, just like we went through the process yesterday of ensuring that our data was formatted, ensuring that we didn't have any sort of fields that didn't have any relationship to our target. You could also add to that pre-processing of the data set something that validates, is this a good prompt for my data, for my AI model, right? And that goes into the whole process of, hey, you need to make sure you do some text pre-processing, make sure that there's no that through regex, make sure there's no patterns that are out of whack that would throw off your model. You could do something like words in a bag process to actually analyze each individual prompt that's being passed in, make sure there's a set of keywords that would actually trigger a specific action within your model. A lot of these things that I'm saying are concepts that we're going to be covering later on, but there is a whole pre-processing portion, just like there was for a multi-classification model yesterday, that you can do to text to make sure that you're validating that data before you even feed it to your model. Does that answer your question, Michael?
Yeah, thank you.
Of course. All right. Does anyone else have any other questions regarding our introduction to chatbots? Let me check the chat here. I see a couple of things are being shared on the chat. All right. I'm going to go ahead and pause our recording. All right. In this second portion of our lecture, we're going to start talking about natural language processing. Now, the portion of natural language processing is essentially just like we did yesterday, when we cleaned up our data to ensure that our data was properly balanced and that it was standardized and scaled. Well, we're going to do almost something similar to this portion of making sure that our data is standardized and scaled with natural language processing. Essentially, what we're going to do is we're going to go through the process of analyzing text. We're going to make sure that this text doesn't have any sort of HTML included in it. We want to make sure that this text is as clean and as formalized as possible. We want to account for capitalizations, maybe getting rid of anything that's capitalized. We want to make sure that we allow for specific indexes or that we're able to recognize how many instances of a character are within a word. All of that is part of natural language processing. Is essentially the process of breaking down a language, right? Breaking down any sort of text language base so that we can actually take a look at it and feed it to a model so our model can make decisions or learn from it. Now, text pre-processing, there's a couple of things there. There's noise removal, which is just what I talked about, making sure that it's nice and clean. There's the process of tokenization for this kind of noise, or excuse me, for this text, where every single word or every series of words are given a tokenized value, which is just essentially a decimal point or a floating number. This allows us to feed it through our actual model. Then there's the normalization process, making sure that our text has been normalized and ready to go. And so that's all going to break down kind of how we took our data and fed it through this pipeline. Well, this pipeline inside of our AI module, or once we're actually feeding it to chatbots, would be our text processing, which is part of the natural language processing there. All right. Now, why regex? Why would I want to utilize regex to take care of anything like this? Well, regex is extremely good at detecting things, especially when it comes to patterns, identifying characters, just text formatting, right? I don't want to have to write a function that identifies if there's a space and how many times there's a space that occurs. I don't want to have to write a function that makes sure that integers are being included in a specific format. Have to account for special characters. Text manipulation in general is a huge dive point if we're only utilizing what Python has to offer and not utilizing something like regex. So regex is just essentially a way for us to do a quick pattern recognition inside of strings, apply that pattern recognition, and quickly know if we can get back a good match or a bad match to that pattern that we're looking for. Now, the way that regex works is it essentially accounts for a one-for-one concept. So for example, if my regex looks as such, and let me actually fix this here. All right, so if I have a regex that only accounts for an A character, and I have an input string that is also an A character, well, it does a one-for-one value. It would create the regex representing A. And it would also create the input string representing A. And the way the regex works is it essentially wants to check if there's any pattern left by the time it's done comparing this string. So in this case, when it works through it, says, all right, well, I have a match for this letter A. I'm going to cross it out. Well, now I'm empty. So this means that I'm currently holding a good match for the input string, because I no longer have something that matches that one character there. Well, with that said, if I have something like AB, now this changes. When I pass in the concept of V, I'm still canceling A, and that canceling of A is happening on both letters there, or excuse me, on both strings there. But I do have a leftover value of B. And because I have a leftover value of V, I would no longer have a good match. It would tell me this is a bad match for the input string because there's a leftover value that I'm not accounting for within my regex. Right, so it's working by a canceling process. It's expecting both of these to be open by the time the pattern recognition is over. I mean, to be empty by the time the pattern recognition is over. And if they're not both empty, we have a bad match. All right. Does anyone have any questions about how regex is actually working as far as comparing the regex string to the input string? Let's hear it, Carlos.
In this scenario, would the order of that input string make a difference if it's BA instead of AB?
Could you say your question one more time?
If the input string was BA instead of AB, um, and your regex was or regex was AB instead of just A, would the order of it matter?
The order 100% matters. Yeah. So if this was flipped around, it's doing a 1-for-1 swap at each index, right? Because that's the we haven't specified if this is, it doesn't matter where it's happening. We haven't specified the number of times it should be happening within the string. It takes it as a face value. So it would try to match A and B. It would see that these two do not match, and it would automatically default to a bad match. Does that answer your question? Okay, perfect.
Yep.
Daniel?
When you're saying regex, is it the same as like regular expressions where we use it as like a filter or a replacement tool or even like a validator for passwords?
Yeah,
Is
so
it the same one?
yes, regex does stand for regular expressions. Awesome. All right.
Thank you.
Other questions? Okay, well, with that said, let's go and start writing out some code. All right. How exactly is it that I can apply regex? Well, I want to apply regex utilizing something called RE. And let's do a quick overview here. You can see that I don't have a kernel that's currently selected. So let me source back into my environments, go into my default, grab my bin, and activate, because that's where I have all of my stuff to be able to actually run this. All right, from there, I'm going to run which Python 3. That gives me Python 3 there. I'm going to copy it, go into selecting a kernel. So Python environments. Doesn't seem like it's able to recognize it. So I'm going to go ahead and grab a VMV there. I'm going to enter an interpreter path, and I'm going to place the interpreter path that I had. Okay, so there's Jupyter. Everything seems to be working there. And let's just go ahead and print hello world. And we get hello world. Perfect. So it tells about your notebook experience. Not right now. All right. So we're able to utilize regex. In order to utilize regex, a regex string is identified by an R in front of a string. And we can utilize a regex string to match a string pattern through RE. And we're going to take a look at RE here shortly. All right, so first let's go ahead and create my regex. Let's say my regex. We're going to do the simple example that we wrote there where we have A, and then we're going to actually create an input string of A. All right. Now this regex here, my regex, that's currently not a regex. It's just a string. How do I actually design it so that this can be recognized as a regex string, as a regular expression?
So put an R in front of it.
Yeah, just need to put an R right in front of that string. And now we have a regex string being assigned to us. And then it tells me, well, you need to utilize RE in order to be able to use this. So I'm going to go ahead and import RE. Currently, right now, I don't expect anything to happen from this. I just want to have this regex string being separated. Let's go ahead and start creating some code now. I'm going to run re.match. And what I'm going to match is I'm going to max my regex to my input string. When I run this, it's going to give me a regex object. Let me see if I can use something like this. If that evaluates to true or false. It doesn't seem to actually show me the evaluation there. If I just run the match property, it doesn't seem to just return a simple true or false, but it is printing or failing. So unfortunately, if I were to do something like if re.match, I would have to actually return true if I was building a function that was doing this. But we can see the input string is actually working. We were able to match it. Let me go ahead and do a print statement there one more time. All right, I execute this. This actually returns a match object. And it tells me, hey, we were able to match A. Well, let's see what happens if we turn this to B and now run it through. We run all. Seems this one isn't actually returning anything in this case. So I'm going to actually print so we can see it. So it returns none. If it's unable to match the regex pattern, it returns none. And if it's able to match the regex pattern, then it returns a regex object. So that's the reason why we can say if re.match, right? If it actually matches, it returns a regex object, which evaluates to truly. That's why we get print match. Whereas if it didn't match, it just gives me none, which evaluates to falsy, and it fails the match. We can come back down, uncomment this information, run it again. Now we get the input string failed. Run this back to A. And now we get that we have a good match. All right, so there's our very simple character for character exchange there. Does anyone have any questions about how to do individual character comparisons here? All right. Well, now that we understand how to do individual character comparisons, let's actually take this code and I'm going to change my regex now. I'm going to change my regex by making it, I'm just going to make a function that will evaluate regex here. That way I can just call the function every time. Currently, I'm going to call eval regex, which holds my regex and the input string. Okay, there we get match. Now I'm going to go ahead and change the value of my regex. I'm going to change it so that what we're currently holding is the value of caret, or let's go ahead and do A here. And let's see what happens when I call that eval regex then. Again, I'm going to pass in my regex and my input string. But when I run this, I still get a match. What does that tell me about these square brackets?
It's not looking for them as a character.
Yeah, it's not looking for them as a character. These square brackets are essentially just saying, hey, within this regex, or actually, let me go ahead and pass that as an R because I just messed that up. Okay, perfect. So it's saying within this regex string, these parentheses there are not something to take into account. These parentheses are simply stating that there is a pattern to look for within the regex. Well, why is that important? Let's take a look here. I'm going to change this pattern by simply adding a caret. Now, when I run this, I get a failure. Well, the only thing that has changed is me adding the caret sign. So what does that mean for the caret sign? What is that representing within the regex?
Except like it's not supposed to be there.
Yeah, it's the equivalent of not. So caret is equal to not. Right? So we are not trying to find A. Now, this caret also means that this is the beginning of the string. And that's the reason why we want those parentheses on the outside. Because by including those parentheses on the outside, we're saying, hey, do not match the pattern within the parentheses. All right. Let's go ahead and move into the next portion there. Now let's go ahead and do my regex. Or actually, let's grab our input string. And let's turn it into AB. Now let's run that eval regex here. Where we'll pass my regex and the input string. All right, well, currently, I'm getting that this matches. Let's see what happens when I take off that outside letters or those square brackets. Well, they still match. So it looks like I was wrong in that context that I mentioned earlier. Who asked that? I think it was Carlos, where he asked, hey, is it going to account for the number of letters? Right, so it still found A. Even though B was still in there, it still evaluated to a good match because I was able to find that first character of A. Let's go ahead and switch these backwards and turn it into BA. And now we get that false statement because A did not match that very first character. And that's where we returned that bad statement. All right, currently we're just talking about individual characters. And I see a question come up. Go ahead, Andy.
Could you please just briefly explain again how when that symbol is used as the beginning of the string or as not?
Yeah, so right now the only thing we've demonstrated is as not. So we demonstrated that here by passing that caret. Let me go ahead and pass that back here. So currently right now, the first execution is where we check if it is. All right, that failed because the letter B is not A. And now what I'm checking is by adding that caret in my regex, I am saying not A. Right, so my regex is BA. Currently, it's going to pass because B is actually not A. So I go to execute that. That worked great. Now I go to execute it here, and we get a match because my regex is not A. Does that answer your question there, Andy?
So if the caret was outside of the bracket, it would see it as differently.
If the caret was outside of the bracket, then it would be representing an anchor, which means that it's the beginning of the string. But we haven't gotten to anchors just yet.
Okay.
All right, let me run. Actually, let me go ahead and clear. Okay, good. So this is my regex. Everything's currently working with my single character. But what if I wanted to do something like alternations? Or if I wanted to find a series of character matches, right? Let me go ahead and take a look here. Let's take a look at alternations next. Now, alternations in regex means that I may want something to check for one condition or the other. So for example, if I have a series of input strings, I have something like, hey, I want cat, I want bat, or I'm looking for a hat. Well, I want to check if this input string has C, B, or H. And this actually will work up here. I apologize, this is still within the single characters. So let's go ahead and create our string here. We're going to do our regex, where my regex is going to be equal to a regex where we'll pass, hey, we want C, B, or H, and then AT. And then we could pass that into our eval regex function, where we can pass in cat. We run that, it looks like we get an error, and that's because I didn't pass in my regex. Okay, we get a nice match there. I can also pass in bat. And I can pass in hat. And for all three of those, we get a match. That is because all three of these characters are allowed. I'm saying, hey, C, B, or H can be allowed inside of this first character set, and then followed by AT. So I find C, B, or H, and then it's followed by AT and gets a match for every single one of them. If I only wanted to get something that matches bat and not cat or hat, well, I would simply just say, hey, I don't want C or H. I only want bat to pass. And that's how we get failed, match, and failed. Now, capitalization is important. Oh, I see a question. Go ahead, Carlos.
Sorry, that expression there, that would be I guess the not CH would just be the equivalent of just replacing that with just B, right?
Sorry, one more time.
So instead of being the not CH, you could just replace that with B and it would equate to the same thing, right? You would get the same result.
Yes, I could just do that. I could just change it to B, and then that would give me the same result. Go ahead, Daniel.
If you replace that with B, then other parameters like if you were to pass the string stat wouldn't work. But if you have it as not ch, it'll look for any other letter or number or special character other than just the ch. Whereas if you pass in B there, it'll only look for that lowercase b.
Are you just assisting or are you asking a question?
I was just saying a little bit of both, I guess. Just this, just trying to see like if my mindset is right or wrong.
No, that's correct. Yeah, so if I pass in B and I pass in any other character, it would still pass. Or excuse me, it would still fail, right? So if I say, hey, B, and then I pass in something like, oh, set, well, then only bat would be passing, right? But if I only wanted for specific character patterns such as cat or hat to fail, but I do want bat and sat, then I would use the not character, and that would turn both of those into a match. Awesome. All right. Now, capitalization is super important whenever we're working here. You'll notice that the moment that I turn this bat into a capital letter, that still passed. I'm not sure why that still passed. I was totally expecting that. Oh, because it's not C or H. There you go. I turned that C in cat into a capital letter when I get three matches. even though I'm telling it not to allow for C, capital C is passing. That is because capital characters are considered separate than lowercase characters as well. All right. Now let's go into alternations. Alternations allows me to capture a series of characters all together, such as this. Let's go ahead and make my alternation. So let's say my regex is now equal to a string pattern, which is yes or no. So now both of these will be accepted. If I go to my eval regex and I pass in my regex again. Oh, go ahead, Andy.
Just before we get too far ahead, I was just wondering, it's kind of counterintuitive with the regex where the entire time that we code, we would separate each variable with a comma some sort of way. And here is just forget everything that you've learned. We're just going to squish everything together. It's just like, is that something that we just have to come to agree with?
I see what you're saying. How before we had to separate every single expression or every single evaluation, whereas now everything's just compressed and in just one single line. Is that kind of what you're referencing?
Yeah.
What I would think about when it comes to regex, I would like to compare it to something like let's do, when we do a for loop. And then from there, we turn it into a list literal, right? Instead of writing everything out in that for loop, creating a brand new list, and then having all that information tossed into that appending function, instead we just do it all within one line, right? Well, that's the kind of like the same concept with regex. It allows us to do all of our string manipulation within one line. And unfortunately, yes, that is kind of the nature of the beast with regex. Everything is going to be just one line and smashed together. That's the nature of the beast. All right. Awesome. So now we're going to go ahead and evaluate our regex here. And what we're going to pass in is this string of yes. Well, you'll notice that gives me a match. Well, if I change this and I turn this into no, that will also give me a match because yes and no are being considered in here. Or if I throw in something like other, that would return failed because it is not within the two alterations that we're allowing for yes and no. You could still write regular regex in here. I can say, hey, I want this to be not y. And then pass that in there. You'll see we'll still get some matches, right? Because lowercase y is not the same thing as uppercase y. All right. So we can still write regular regex inside of these alternations. It's just a way of saying it could be this or the one next to it. So let me go ahead and change this markdown here. And I'm going to change this to add the keyword of or. All right. So now we've gone over how to evaluate a single character. We've talked about alternations. I can go ahead and continue doing my alternations here. And keep in mind that this regex pattern is trying to find this alternation anywhere within the string. It's no longer just trying to find it at the beginning. So let's go ahead and add a different code block here. And let's do my regex. And let's make that equal to a regex here that says apple, orange, and banana. And let's try to evaluate that. And say, I like orange juice. Well, now when we evaluate this, it seems like it has it as failed. Interesting, and it may have it as failed because it's not the first one. Let's see if that changes if I do this. Yeah, so it does still expect it to be first. So that's a good thing to point out, right? It expects it to be first. I can change it to be banana. That can still pass within my regex. I can even change my regex to similarly say I like apple, orange juice, or apple, orange, or banana juice. And then we can add that in there. Say I like banana juice, and this would match. Let's see. Oh, oh. I like banana.
I think it has to be I like apple, or start with orange, or start with banana juice.
I might got that confused. Could you give me one more? Can you say that one more time, Michael?
Your sentence in the eval has to start with either I like apple as a whole beginning, or start with the word orange, or start with the two words banana juice. I don't think it lets you mix I like and then banana juice.
Saying maybe he needs to toss some brackets in there to get the
Yeah.
behavior he wants.
Probably.
Doesn't do that. There you go. Thank you. Good catch, everyone. So it looks like what we needed was to isolate that behavior, and you do that with some parentheses there. So there you go. We get I like, and then it's able to accept apple, orange, or banana. All right. Currently we have banana. I can now change it to orange and execute that. That would still match. I could change it to apple. That would still execute correctly. And if I change it to something like, I don't know, beet juice, that would fail. All right. I saw a hand go up. Go ahead, Andy.
Does the regex by default match everything that you input unless you give it some other function?
Yeah, so just like you see here, I have I like and then space. So it's looking for I like and space. It's matching it one for one. Here's where I'm actually throwing some dynamic context in there, where I'm saying, hey, we can accept either apple, orange, or banana. Then there's space, that white space is cleared there, and then juice. Right? So if I change this back to apple, it's expecting that exact pattern there. Does that answer your question, Andy?
Yes, yes, it does.
All right, perfect. All right. Well, now let's start talking about a more complex portion of characters here. Let's say we wanted to find a series of characters, or we wanted to identify a range of characters. Go ahead and add some markdown here. Start talking about range. Let's say I have something as simple as I want to identify if the word hello is written. Or let's say that I just want there to be, so I want to check if a word is in title format. Now, Python does offer us a title format that we can easily utilize. But if we're working inside of something like SQL or something inside of JavaScript, we may not have a title format that we can easily utilize. But we do have regex available in both of those languages. So I'm going to go ahead and create my regex here. And I'm going to specify that what I'm looking for is for any capital letter that runs from A through Z, and that is followed by lowercase letters of A through Z. And I could actually utilize a plus sign, and that plus sign at the end means we are looking for one or more instances from the previous condition. So I only want one instance of A through Z. So for example, I can put hello. I have one specific instance of capital A through Z. And then I have one or more instances of a lowercase letters between the alphabet in A through Z. All right, so now I can run this regex here. I can say evaluate regex, pass in my regex, and just pass in hello. Well, when I run this, we get a match because we have a capital letter. If I change this to be a lowercase letter, it would fail. And it fails because A through Z did not match, right? Or the capital A through Z did not account for lowercase A through Z. All right, so let's turn that back here. Let's make that back into a capital letter. And let's see what happens when I take off that plus sign. Well, now it's giving me a match because it's expecting this information. But what if I were to add a dollar sign there? Well, that dollar sign is an anchor demonstrating the end of the string. Well, now when I run this, it tells me, hey, this fails. I have no idea why you have more letters. I'm only supposed to be a total of 2 letters, one being a capital letter, and the second being a lowercase letter. Well, we add that plus sign back again to say you could have one or more instances, and now we get a match. All right, so now we're talking about range there. And again, if I add a caret at the beginning of my regex, that caret is an anchor. Demonstrating the start of the string. And actually, let me just move all of these up here. And let me take this with me as well. All right. So there we broke down our regex. We have the start of the string, followed by a capital letter. And then we have a series of lowercase letters where we have one or more between A through Z, all the way into the end of the string. And we have a match. All right, let's see what happens if I take off all of those letters there. And all I have is H. Well, now I get a failure. And I'm kind of going into some special characters here. And that failure that I'm receiving is happening because there is no instance of A through Z. Well, I can account for that utilizing the asterisk method. So by utilizing the asterisk method, so plus means we're looking for one or more, where star means we are looking for 0 or more. I think it's more. Let me go ahead and do HE there. If I do HE, that should still pass. And let me finish off by passing off hello. So hello still matches the pattern recognition. So again, plus sign means 1 or more. Star means 0 or more. All right, go ahead, Michael.
With the star or the plus, are you allowed to put in spaces?
With the star or the plus. If I want to put in spaces, I would actually have to demonstrate that. So I would have to say space. Oh, I see what you mean. Do you mean like this?
Yeah.
So space within the input string itself. Got it. Let's run that there. So spaces are recognized as a different pattern that's outside of A through Z. All right. So the star is looking for A through Z. It matches H and L, but then it ends. This white space here is not recognized within the concept of range A through Z.
Got it. Okay, thanks.
Of
If you
course.
toss a space right after the lowercase z in your regex, would that go then?
Now let's try it out. So now it matches because it's also accepting a space. All right. If I wanted to do something like separate words, like let's say hello world, I would do something like this. I would then pass A through Z, close it off, and then A through Z, close it off with plus sign. I would actually change it for plus signs because I do want one or more instances in this case, right? Since we're looking for words to be in title format. And then I would run it. So now it's looking for 2 words in specific to be in A through Z. I could even do it this way, where I can say, hey, I want to look. So right now, if I run it, this is going to fail because it's expecting only one word, right? Well, I can wrap this up and say that there is one or more of those words represented. And that, of course, would
I
fail.
think it's because you're carrot up in the front. Maybe.
I don't think
The
so.
space.
There's a space somewhere. Oh, yes, the space. Because if I take off that space, now it matches. Yeah. So it's accounting for that space. So I guess I could do something like question the space. Okay, we're going too far into regex, and I might be skipping a couple of steps. So let me backtrack a little bit here. I'm going to pause here with this portion, and then afterwards, we'll start talking about optional parameters or the wildcard first. All right. Any questions regarding regex up to this point? Perfect. Well, just like we've talked about regex in the fact of being able to have range within letters, we also have range within numbers. So I can specify now that I have my regex, which maybe what I'm looking for is a series of numbers, or I'm just looking for any number within 0 through 5. Well, I can evaluate my regex. That takes in my regex and the number 5. Notice that I'm not passing in integer 5. This is still a string, just holding the number 5. If I pass in 6, well, that fails. And this regex actually goes all the way up through 0 through 9. All right, so the moment that I turn this into 10, it gets a match because we're finding that 1, But just like everything, if we signify that, hey, this is the end and this is the start of the string, then I run it, I get failed. All right. Now it's failing because it matches the 1, but 0 does not match. If I add a simple 0 through 9 there, and then I run it, then it's able to match it. All right. Does anyone have any questions regarding ranges? Let's hear it, Carlos.
So if you, that's just checking for 0 to 9. What if you do like 0 through, I don't know, 20? Is that the same thing, or is it just kind of looking for just checking for a digit to see whether it's a digit or not?
You can't do 0 through 20, so it's not a range as in a numerical value. It's still recognizing this as a character set. So it's recognizing the characters of value 0 to the character of value 9. It's not actually doing like a mathematical function there. It's just looking for character values,
Gotcha. Thank you.
of course. Any other questions? All right. If there aren't any other questions, let's go ahead and start diving into the wild card. Now the wild card is pretty simple. We can go ahead and say my regex and say that we have a regex that holds wild card, or let's do C anything T. So the period represents a wild card for anything. And let's pass that into our eval function there. So I'm going to evaluate my regex here, where I have my regex. I can do something like cat. Cut. We could do something like cite. Now, when we run this, we can see that we get all 3 matches. We could even do something where we have a space, and we would still get a match. A, U, I, and space are being considered as a wild card. Well, now, what if I wanted to actually account for a period? Let's say we want something like by and then period. That's what we want within our regex. Well, if I go to eval, and let me actually make sure that this is that it's tracking. This is the end of the string, and this is the beginning of the string. Go to evaluate our regex there. We pass in my regex, and we pass in by. Well, this fails. And it's actually able to identify it. Oh, because it's a wild card, so it's actually able to identify it, right? But if I do something like capital T, this still passes even though it should fail. I want a specific period to show up. Well, we do that by escaping. I can escape that period. Now we see that it fails. And if I bring it back to the period there, oh, that's the wrong escape. There you go. So that matches. If I change it for a capital T, it will fail. So that backslash signifies an escape for special characters. If I wanted to see a slash, I would have to do backslash backslash. Oh. And there we would get a match. Because even in string, you have to have a backslash backslash. All right. Does anyone have any questions regarding wildcards or the escape character? All right. If no one has any questions, so let's move on into our groupings. And I see we are starting to run out of time, so I'm going to try to step on the gas, everyone. I apologize here. So groupings, pretty simple. Let's go ahead and take a look here. Groupings are a version of range, meaning we can specify how many times we expect to see a pattern. And can accept a min and max. Min, max. So let's go into defining that. Let's say we want to identify a phone number. I want to have my regex be able to identify a regular expression where I am capturing 0 through 9. And I know that I want this to exist 3 times. I then will have a dash. Again, 0 through 9. This will again be 3 digits. And then finally, 0 through 9, where I'll take in 4 digits. Now, if I try to pass this into my evaluate regex function, I can throw in my regex and pass in 555, which is 3, 555, again 3, and then 1, 2, 3, 4. All right. Well, now when I run this, we get a match. We had 3 instances of the character of 0 through 9, 3 instances of the character of 0 through 9, and then we had 4 instances of the characters 0 through 9. Again, I can specify a range such as 3, 4. And now if I run it, it tells me, all right, we got the 4 that you wanted. What happens if I add 4 digits into that middle number? Okay, it fails. And if I put 3 digits towards the end, well, that matches because it met my minimum. Right? It's saying I need a minimum of 3, but I can go all the way up to 4. All right. Does anyone have any questions about groupings? All right. If no one has any questions about groupings, then let's go into our optional parameter here. So for optional parameters, what we can pass in, and say we're talking about something like a month. Or we have a specific set of patterns that may be just optional, right? Let's say I have color, and I want to make it optional to actually have, I think the month example is better. Identify a month by either the first 3 letters of the month and have the end pattern be optional. I'll go ahead and create my regex for November, where I'll say, hey, NOV is required, but Ember portion is actually going to be with a question mark. I may or may not have it. Gonna put that into anchors, showing that that's where it starts and that's where it ends. I'll go ahead and call my eval regex function, pass in my regex, and then actually pass in November. Well, now we have a match. November fits the specs that I'm looking for. Well, what if I take that off and I just pass in NOV? We still have a match because NOV is what I'm actually looking for or is required out of my regex. But the remainder of EMBER is actually optional. I may have it or I may not have it. And I'm not worried whether it shows up or it does. Let's say that we have color versus color or color. So I have my color and I have color. Well, what I can do is I can make a regex that says, all right, what I'm looking for is for color, where I may or may not have the letter U, and then return that. And now we can see all three of them are matching. All right, let's hear it, Michael.
For the November one, what happens if you put like NOVE, but not the entire rest of November?
If I put in one more time,
Just like an E at the end, so it's part of the optional.
yeah, let's go ahead and run that. Well,
So it
now,
requires the whole thing.
yeah, because it's looking for the whole thing. It's either all.
Okay.
All right. Any other questions? Okay, so let's just go ahead and revisit that. Actually, before we go and revisit this, I think we would get more out of taking a look at a couple of other things here. Pretty sure it's this one. All right, so here in Regex 101, you can actually select the language that you're utilizing. You can type in a regex. So let's say we have here our color. And we pass it in. And we pass in our text string of color. Well, it looks like it's already looking for the regex portion. So let me go ahead and there you go. So we pass in the regex that we've created, and it's actually able to tell me, break it down step by step, how it's working and why it's working. Right, so it's a really useful tool. Strongly recommend everybody to use it when you're tackling the assignments later on. Please know that RE doesn't just have the matching function, it also has the search function. All right, so today we were only able to dive into the match function, but RE also has the search ability and it has the find all ability. There's a difference between those three. There's match, search, and find all. You'll be required to utilize them today, so please make sure that you take a look or take the time to do a little bit of research and within those nested methods. Carlos, I think I saw your hand up.
Yeah, you said you can use regex in different languages. Are they the same syntax?
They are. I think there's small differences between Python. Python and JavaScript are very similar. There might be a small difference as far as like special characters go, and same thing with SQL. Um, but the functionality of exclusion, inclusion, grouping, that all remains the same. There may be just small syntactical difference. Does that answer your question?
Thank you. Yes, sir.
All right. All right, everybody. This is going to be where we're going to conclude our lecture regarding our regular expressions. For this afternoon, there are a couple of assignments regarding regular expressions. But before I go into that, does anyone have any questions or any clarification that they need in regards to regex? Perfect. If no one has any questions, I'm going to go ahead and stop the recording here.